Hey, what's up everyone, and welcome back to another episode of Naked CTF. In this series, I will attempt to compromise and own a server from HackTheBox. This is my first attempt. I've not solved it beforehand, nor read anything about it, so it's done as one take with no editing. So this could be a 30-minute or a 3-hour video. Let's get started. So today we are doing Precious. So let's get ourselves set up with some automation. So we're going to do CTF HDB. We're going to put in the name of the box and the IP. Let that go. Okay, we're now somewhat set up. Let's go CTF HDB Precious. And as always, we'll start with our enumeration. So nmap minus, let's check we've got our IP correct. Yep, that looks good. Our local IP is going to be ×0. All right, nmap minus sc minus sv, all ports. vv, t4 timing, and output to nmap1.txt, and then our target. All right, that is underway. While that's going on, I might just quickly flick over to HackTheBox itself. I have been doing or attempting some seasonal boxes. So at the moment, we're in season 5. I was able to complete Solar Lab, both the user and root flag, which I'm pretty happy about. It took me a long time. I think it was about 3-4 hours, maybe even 5 hours. And then the one that's active at the moment is Magic Gardens. This is rated insane. I've had a good crack at this. I haven't been able to get a foothold yet. But if you're unaware, with HackTheBox, you need to do seasonal boxes. So every week in this season, I think it's every 6 or 7 days, a new one unlocks. The next one after Magic Gardens is Board Light, which is in 4 days. And that's what actually gives you ranking. So I've only been doing retired boxes. For seasonal boxes, you're not allowed to stream them, obviously, because you don't want to unveil how the flags are obtained. So for Naked CTF, it's seasonal only. It's retired boxes only, sorry. But yeah, this has been a lot of fun. Obviously, I do this in my own time. Tackling a medium box was definitely a challenge. It was a really, really big challenge. But yeah, completed it and super happy with that. Magic Gardens, I don't know if I'll make any progress there. There's a lot. I did a lot of enumeration. Wasn't able. I thought I found the foothold, but I wasn't able to quite crack it. So I'm going to keep working on that in my spare time. But for now, we're going to keep going with some of these retired boxes. So as always, we're going to do adventure mode, try and capture the flags. If we need to, we can jump into guided mode, and if absolutely necessary, we can look at the walkthrough. So this should be done by now. There it is. And let's just grab a copy of the output from nmap here. So I'll take this. Looks pretty straightforward, just 2 ports, SSH and port 80. And if we look, our notes template should be here. All right, let's close that, paste in our recon, and we can go from here. Let's have a look. So SSH, pretty straightforward. Debian is in the banner, so we've got an idea of the host operating system. And then port 80, we have Nginx, so we don't actually know what, it's unlikely that it's Nginx directly serving the content. It's probably redirecting to, it's probably reverse proxying that traffic to another web server process. That could be Apache, it could be anything really. Straight away we see there's a 302 or a 300 redirect to precious.hdb. So I would assume if we take this IP and we put it in the browser, we're going to get, let's just open that. We're going to get, yeah, a 302 redirect. Because this precious.hdb doesn't resolve, we need to add that to our local host file. And so that's going to be IP precious.hdb. And now if we ping precious.hdb, good, that looks fine. And let's have a quick look. So what are we going to do next? 22 TCP SSH, we will leave alone for now until some credentials appear. And then port 80, TCP, HTTP. We're going to do casual browse of website, look for any interesting opportunities, and if need be, we'll do directory and file enum as a next step. That's about all we can do with this particular box. So now that we've got our precious.hdb resolving, we hit refresh. Okay. And straight away, we hit this homepage, convert web page to PDF, enter URL to fetch. All right, well, let's just try http google.com. And what does it do? It would imagine it's going to take a screenshot of that website, maybe using a headless browser, and then spit out a fake URL. Okay. Now, I cannot load remote URL because this box, like most CTF hosts, doesn't have direct internet access. It doesn't have outbound access, obviously, because that would be a big avenue for abuse. So what we might do is set up a very simple web server. And let's go CTF HDB precious. Let's make a directory called web. And in here, let's do vim index.html and go h1, please subscribe. So we'll create our own website, super basic website, and we'll see if we can get that to work. We need to launch a web server, so we're going to use Python 3 -m http server. Yes. So that will be, the URL will be my IP address, which is 10.10.14.4, port 8000, because that's what our web server is listing on. And then we're going to request index.html, hit submit. And there you go. So we see a PDF of our basic HTML website. That's pretty cool. It actually downloads, so it returns a content type or something like that. So what we probably want to do is just take a quick look at the homepage source code. And for some reason that is taking its time. We'll kill that for now. View page source. And hopefully we don't have any networking issues like we've had sometimes in the past. You can see the web request there. That's the CTF box we're working with. So let's go to here, ping IP, we're all good. Ping precious.hdb, we're all good. Same IP. Oh, there it is. Just took a little bit of time to respond. So this is a really simple website. The form action is post, and the form method is post, I should say, and it's going to post to itself. So it's not posting to /generate or anything like that. There's two inputs, a text and a submit button. The text name is URL, and cannot load remote URL is probably just left over from last time. Let's try that again. And put that in. And look, it's pretty fast. You get a random file name as the for the PDF. So, I think we want to do some further enumeration on this. So what we might do is fire this up in burp just to inspect the headers a little bit more. and anything else that might appear in the actual request response. And we can just see that flow a little bit better. So we're going to turn on intercept, and we've got an empty history here. Then we come back and we turn on our proxy for burp, hit submit, and we go back to burp. So here we can see the post. Our URL is in parameter is here, and then it's URL encoded, which makes sense. So let's forward that, and then go back to the history. And we may want to turn off the filter here for binary content. So we probably want to turn on images, other binary. Yeah, that should be okay. So our history. All right. So there's our post request. And then this is what comes back. So directly from the post request in the response, it doesn't go through a redirect. We can see the PDF data here, binary data. Lots of funny looking characters. We can see it sets the content type to application PDF. It sets a length, so this will be the number of bytes included in the body here. Here's the randomly generated file name. What else? Okay, so really interesting here, powered by Fusion Passenger. So Fusion Passenger is the Ruby web server, I believe. It's kind of like the built-in web server that is powered by like a gem in Ruby. Kind of like how in Python you've got this HTTP server module. It's got its own standalone HTTP server. So let's just make some notes as we go. Okay, basic web app that takes in URL, spits out PDF of page in response. Okay, so the nice thing is we have control over HTML input. So we can feed HTML by pointing it to our own web server. What else? So we saw Nginx here, but the header has got Nginx 1.18.0 plus Fusion Passenger. So I think the request goes browser, Nginx, Fusion Passenger. Okay. Let's grab the other header. This one is good. And we also wanted, yeah, this X runtime, just to make a note that we have a copy of that header going forward for our notes as we progress. So what do we want to try next? We want to look at possible injection from HTML to Ruby app. We want to look at Fusion Passenger exploit. We want to look at Fusion Passenger and or Ruby exploit. We want to look at Nginx vulnerability, but I'm going to rate this as unlikely. Maybe a last last chance, last option if we really get stuck. So here's the PDF. What it looks like in the response, the HTTP response, is we've got some PDF output here. I don't know the PDF binary file structure that well, but it does have some metadata here before it starts spitting out the actual content. All sorts of things like fonts and positioning and yeah. So I think this is probably important. HTML to PDF 012.6. Let's grab that. PDF output. Ooh, okay. So it's got some Unicode in there. So let's just tidy that up. HTML to PDF 0. What was it? 12.6. Okay. Producer is Qt 5.15.2. Qt 5.15.2. Now, if I'm taking a guess, this is a library. And this is a library used by HTML to PDF. Qt is a set of graphical components. I don't actually know. It's kind of like a standardized UI toolkit, I thought. Something along those lines. So, yeah. Let's... what should we do? Because of the straightforward nature of the app here, and the fact that in our enumeration there's nothing except SSH and this web app running on port 80, I think this is our best course in terms of what to continue to further enumerate and try and exploit. There is absolutely zero in here. We could do some directory enumeration, see if we come up with something else. So let's do that. URL is http precious.hdb fuzz word list is going to be user share word lists, sec lists, discovery, web content, rafts, then directories, medium, directories, usually do lowercase for a Linux server, and then we're going to send the errors to null. So we'll let that go. Maybe this will turn up like a subdirectory of something interesting. You know, there's always a good one to try as admin. And let's see if that gives us anything. It's taking a long time to respond to the request. Maybe it's getting hammered by the enumeration here. Yeah, so it turned up nothing. Nothing at all. Let's reload. Okay, stop. Yeah, this web request is taking a long time to complete. Let's grab this URL while we wait. So we've got our kind of payload URL. Payload URL. Okay, come on, let's go. HTTP precious.hdb, and I think my networking has gone down. King precious HTTP. It's still there. It might be my DNS. Yeah, look, I've got some configuration issues I need to take care of. Let me just do this. System CTL stop tail scale service, which I think it's hosing my DNS config. And we ping google.com. Yeah, it's okay. How about now? HTTP precious HTTP. Box is still up. Yep. VPN is still up. Okay, that's good. What are we missing here? Precious.htb. What I might do is just restart my VPN and see if that kicks it into life. Okay, IPA. Yep, good. Precious.htb. HTTP precious HTTP. Absolutely nothing. Well, given that. Oh, my goodness. I have just made an absolute rookie mistake where I am sending it through burp and intercept is turned on. Okay, all right. The problem exists between the keyboard and the chair. Or it's an ID 10T error. Right. Where were we before I absolutely owned myself? So we've got our payload URL. We know what the request response looks like. Bang, bang, bang. If we send this to host, we can send this to the repeater. And we can run that. And we get a response. We can run that. We get a response. We get a PDF. Brilliant. Okay. So, Fusion Passenger. Let's start with that. Fusion Passenger. Exploit. Let's add the version number. 60. Let's just do 6.0. Okay, so this is the release notes. File access through directory traversal. Fusion Passenger before 403. Well, we're much, much further ahead than that. Let's just try 6.0. Fusion Passenger. Okay. This is kind of complaining about the CVE publishing process. Please use CVE to refer to this vulnerability. We cannot provide a unique CVE ID for every application that has been shipped with a vulnerable version of curl or libcurl. Okay, so Fusion Passenger uses libcurl. That had an issue. But what's this particular CVE? So this is a curl bug, SOX 5 proxy handshake. Resolve the address, blah, 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 blah. So given that Fusion Passenger and curl are probably not going to be acting as a SOX 5 proxy, I think we kind of park this for now. Nginx, let's just quickly check. 6.0. Yeah, there's no obvious like CVE for that. It's all referencing older versions of Passenger. Yeah. Let's just have a look at the homepage, make sure our understanding of Fusion Passenger is correct. App server that runs and auto-manages your web apps with ease. Also improves security, reliability, and scalability. So it's kind of like a container. A runtime container for web apps. Kind of like Tomcat, I think, would be a good equivalent. Generic language support. Anyone who'd like to contribute. Some are for fringe frameworks, others are for the likes of .NET. So Rust, Go, Java, Swift, Elixir. Okay, so it's not generic to Ruby. Okay. Let's do Fusion Passenger Ruby. Here's the GitHub homepage. Fast and robust web server and app server for Ruby, Python, and Node.js. It looks like they've gone a bit beyond this and can take most languages and frameworks and that sort of thing. Latest version is 6.0.22. So we're not far off the latest version. We're actually only a couple of minor versions behind, and that's only 6.0.22 is only 3 days old. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is September 1922, so not old at all. Compilation error. No, like, we fixed this RCE bug or anything like that. Nothing kind of super obvious. One thing we should do is search exploit Fusion web server 1.0, 1.0, 1.0. Yeah. And they're all for Windows. Okay. So let's park Fusion Passenger as something that can be potentially exploited. I want to read a little bit more about this. HTML to PDF. Client-side HTML to PDF rendering. Okay. This is a client-side JavaScript, though. And we don't see any reference to it running client-side here. There's no action to run a JavaScript function. There's no link to JavaScript. So I don't think it's a client-side PDF generator. Written in PHP. Let's do HTML to PDF Ruby. PDF generator from HTML gem for Ruby on Rails. Yeah, it seems like it's a fairly generic name, like format to format. This project name has the -rails, so I don't know if it's the one we're looking for. because if you look at the request response, it's kind of like by, then some funny Unicode characters, HTML to PDF. Let's include the version number, so that might give us a more specific, it might narrow down which package it actually is. 12.6. Oh, it is. Okay, so it's not HTML to PDF, it's WK HTML to PDF, which you can kind of see there. Yeah, so the by is in this weird Unicode, and then WK HTML to PDF. So it has got a unique name. WK. Showing results for WK HTML. Oh, and then it's 2 TO, not number 2. Okay. Let's find the home page. WK HTML2 TO2 PDF and 2 image are open source command line tools to render HTML into PDF and various image formats using the Qt WebKit rendering engine. Okay, so that explains what we're seeing in the metadata here. So WK HTML2 PDF is the CLI tool, and then Qt WebKit is basically a rendering engine, kind of like the headless browser thing that I was talking about before. So if you run this tool and you give it a URL, it will spit out a PDF. All right, very cool. So what it means is that when this request runs to produce this response, it is running a shell command, essentially. It's running, so the logic is it'll pass the URL to this WK HTML to PDF command line, and that will generate the PDF, and then it will stream it back in this response. Okay. I want a C library. Okay. So we're going to assume that it's not using the C library, because interfacing Ruby to a C library, I would imagine, is possible, but a little bit unconventional. Yeah, okay, here it is. This is kind of the man page. Okay, pretty flexible. All right. Okay, I don't think we need to read all of that. That HTML2 PDF Rails is not what we need. This HTML2 PDF.js is not what we need. And if we type in the component, the specific version name, so let's find out what the latest is. 0.12.6. Okay, so it looks like, oh no, this is a historical release. So this repository has been archived by the owner on Jan 2, 2023. So what is going on? It looks like development has stopped. Last commit kind of 2 years ago. But it doesn't say, you know, no longer under development. anything like that. They've just archived the GitHub repo, and the last release was 2020, 0.12.6. Okay. And it looks like, given the auto suggest, autocomplete for search, there is an exploit. High vulnerability in WK HTML to PDF 0.12.6. Mandiant reported a high vulnerability. And there's an entry in exploit.db, so we'll have a look at that. Here is a blog post on how attackers can exploit SSRF. Okay. Let's just have a read of this. It's from some university in the US, it looks like. An attacker could exploit this vulnerability to get initial access into a target system by injecting iframe tag with initial asset IP address on its source. This allows the attacker to take over the whole infrastructure by accessing their internal assets. Okay. Yep. That sounds like something that we would want to do. So here's an example. This is not an exploit itself, but it's an example. Okay. From HTML, so that would be our URL. Request verification token. So it doesn't even look like we're bypassing this token, because we don't see like a SSRF token anywhere in this request, right? There's no cookie, there's nothing in the request response. So we're more interested in what might be going on here. Let's just update this. WK HTML to PDF. And then we'll have a deeper look in exploit.db. Search exploit WK HTML to PDF. Okay. Right, so just that one entry that we're looking at here. Header, PDF structure, data, PDF structure. And so if you include an iframe, you can hit this, right? So this is tested on Windows. Let's see what else. Exploit notes. Create a PHP payload to read local file. And start the web server local machine. Okay. So we include okay. File inclusion vulnerability. Let's see what Cyber Guy has to say about this. Through the 0 day, the attacker can get initial access to the internal assets and gain unauthorized access to functions, informations of the compromised assets. This means you can gain access and surf the internal infrastructure anonymously without getting caught. Okay. All right. I'm going to add the payload. It should HTTP da 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 da. Okay. All right. Okay, this is an example how they access an internal Cisco management tool. All right. All right. I would think I would think let's get the CVE. Let's see if there's a POC available. POC. Okay. All right, let's do some testing. Let's go back to our payload that we control. So index.html. And now let's add iframe source equals http 10.10.14.4 8000 / ping. And is it just that iframe source? Okay. Iframe source. Yep. Okay. So if we save that, start our web server again, and then we run our PDF conversion, cannot load remote URL 10.10.14 index.html. Okay, so it gets, and then we see the ping, right? So it renders the iframe tag, which causes a callback to our box. So, how do we escalate this? So this would need to be dropped on the victim machine. Okay. SSRFI exporting parse URL to read local files. So, what payload can we put in here to read local files? So LFI example. Okay. Okay. I'm just trying to think, like, what can we put in our index.html payload to obtain an LFI? Oh yeah, we can use the file handler. Okay, of course. That makes sense. Let's try that. So we'll do file / and then etc password. And the content of that should show up in the HTML, the PDF output. Okay, maybe it doesn't. Okay. Yeah, so it's kind of a XSS. Maybe if we do the same request in... Do we get some plain text output somewhere? No. All right, generated by PDF kit. That's a bit weird. So at the top, we've got WK-HTML to PDF 0.12.6. And in this metadata, the RDF, PDF kit 0.86. Okay. Let's query this. Maybe it's not this. I mean, this is vulnerable though. What about PDF kit? Oh, okay. So command injection. Where the URL is not properly sanitized. Okay, so there's the CVE. Oh, this is actually using Precious as an example. Let's have a look at the payload. Origin, target address, referrer, target address, URL. Okay, I mean, that's a whole working payload. So it looks like this is the right vulnerability. PDF kit, WK, HTML to PDF. So what's the relationship between these two? PDF kit Ruby. Ah, okay. Now it makes sense. So PDF kit. Yeah, so let's just kind of document this flow. Browser, Nginx, Fusion, Ruby, PDF kit, and then that calls WK HTML to PDF. Right, so the vulnerability is in PDF kit, not in WK HTML to PDF. Okay. What is it? 0.86? 0.86 exploit. from 000, a vulnerable to command injection where URL is not properly sanitized. Commonly used, so gem is the packaging, kind of like an npm module or a pip module for Ruby. Okay. So let's take a look. And this includes a reverse shell. So it'll generate a payload. Okay. And if we look at exploit DB, instead of WK-HTML, we look at PDF kit, command injection. Okay. So the one that's in... Okay, look, we'll try this out. But I do want to read through the code and understand it a little bit better. So we will move into CTF HDB Precious. We will make an exploiter. CD exploit. Bim. PDF kit 1.py. Paste in all of that. Save. Oops. Save it. And let's just reduce it a little bit. Right. ASCII art, always important. Help menu. Reverse shell mode. Custom command mode. So you can either send one command or ask for a reverse shell. URL of website running vulnerable PDF kit. Blah, 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 blah. Loading. Okay, a little spinning ASCII character. Very important. Run the exploit. Okay, so it's saying if you're sending a single command, wrap it in quotes. If you're asking for a reverse shell, make sure you have a listener ready. And then, okay, so this is the actual execution. Okay. Make sure the argument's correct. Where is the payload though? Payload. 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 Okay, so that's for a single command. And then this is for a reverse shell where it runs Ruby and then spawns a shell connecting back to us. Okay, so depending on which command line arguments, it will alter the payload. Good. Okay. All right. Still don't fully understand it. I want to look at the okay, let's close this. PDF kit 08 6 vulnerability. If the provided parameter happens to contain a URL encoded character and a shell command substitution string, it will be included in the command that PDFKit executes to render the PDF, which I'm assuming is, yeah, running. So the flow here is that PDFKit can be escaped with the URL itself. And then when that value gets passed to WK-HTML to PDF, you can basically bust out of the command execution here. You can bust out of the string that's being passed. Okay, so it's simply HTTP %20 and then a backtick. Backtick command backtick. Wow. Okay. Cool. I might try writing some vulnerability code for that another time. But for now, let's make sure we've got some progress on our box. So let's do control. Oops. And set up a listener. NVLP1337. Go back up to here. And then we're going to Python PDFKit. So we want to do -s. Local IP is ton0 1337. And then the URL of the website is going to be http precious.hdb. And then it's going to be host parameter is going to be URL, which is this one here. So technically, we could try this ourselves. HTTP, what was it? %20 backtick ID backtick. You should provide a valid URL. Okay. Let's see. Yeah, straight away. %20 backtick. All right. Not going to complain. All right. Let's try and upgrade our shell here. And I've already forgotten the Python command, spawn. Nope. Yeah, Python 3 -c import pty.spawn bin bash close single quote. There we go. It's a little bit better. So we're in var www to pdf. Okay, so let's just take a second here. Obtained rev shell by exploiting PDFKit gem, not WK-HTML PDF to PDF directly. Let's grab a copy of the code that we used. And we are Ruby. Ruby. Okay. Then what do we want to do? We want to... let's see what users are on the box. Home. Okay. 2 interactive users. Henry and Ruby. etc password sh. So Ruby's home directory is actually here. Uh-oh. There we go. No SSH key present. If we go back to var www HTML, I think that's going to be the default Nginx page. Yeah. Okay. The PDF app is where we're at. Right. Let's do... There's no Git repo or anything like that. So what's in PDF? Nothing. What's in config? Basically, I'm just hunting around to see if there's any useful information or credentials or whatever it might be. Yeah, so this is not a full-blown Rails app. This is just kind of more raw Ruby application. Nothing useful there. Let's make this a bit bigger. Controllers. Okay, I imagine this is where the hard work's being done. Oh, okay, Sinatra, different framework. Similar to Rails. So routing is, it'll display this ERB template. And this is where if you do a post, it'll create a new random file name for the PDF. And that's where it runs PDF kit, which is being PDF kit is the vulnerable gem. Interestingly, exif tool overwrite original all creator generated by PDF kit 086. Okay, so it's making sure that this metadata generated by PDF kit is included in the PDF. So it's the author of the CTF box who's making sure that this mention of PDF kit is actually in the PDF file itself. Okay. Very cool. Views. So this is just going to be the home page. Cat index.erb. Yep, that's what we expect. All right, nothing in app. We didn't check sudo, and we don't have the password. So no passwordless commands, and we don't have the password for the Ruby user anyway. Public should just be static HTML, yeah, images, style sheets. We won't look through that because we see them on the from the browser itself. Gem file is the includes basically, so where all the gems come from. Okay, yeah, PDF kit, all the stuff for Sinatra. Gem file. Yep, it's all normal. And config.ru. Run PDF controllers. Okay. So we've got a rev shell. Nothing in the home directory. Home Ruby. Sorry, home Henry. Oh, we can see in this Henry directory. Henry. Nice. So why can we see that? It's because... Okay. Cat user.txt. No, we can't. Okay, so we need to be Henry to read that file. What else? No key. Temp passenger. See what this is. Oh. Silly. Whoa. So it looks like passenger creates this temp directory. But okay, we're not going to be able to read this, are we? Full admin password.txt. No. Because it's read write for root only. What else? apps.s. Denied. Web server info. That's just a lock file. Okay. So we need something to pivot to Henry, I would think. But at the moment, we got nothing. PDF app. So read, write, execute, read, read. Yeah, so we have read on this. Nope. Nothing there. Normally there's some sort of credentials, but not necessarily. Musterman, PDF kit, rack. Okay. So they enforce this version of PDF kit. Okay, so config. Nothing there, right? Okay. Nothing in the controller. I just want to double check. So I kind of skimmed it before. Nope. Okay. What could we do? We could run the P's. Because there's nothing we can do as sudo. Nope. Is there any cron jobs? Nope, nothing. All right, we might be needing a hint here. Fusion passenger. It was it's 1-X runtime. X runtime. PDF kit. CV was this one. Okay, we've made it this far. Okay, which directory located in the running user's home directory used by bundler to store configuration files? Bundle? Ah, okay. So, found in home Ruby dot bundle config. So if we go back to the app, right, that's the piece I was missing. var www PDF app. And you go to config.ru. No. Environment.rb. There should be an include somewhere. that mentions that home ruby.bundle path. Gem file. Gem file.awk. Nope. So bundler is the kind of gem package manager from what I understand. So let's try su to Henry, and we'll use this password. Hey, and now we're Henry. So what we can probably do is SSH Henry at IP. And then use that same password. Yeah, okay. So this is local Linux user. Then we can do cat user.txt. Okay. This is .bundle. And then sudo -l. So Henry can run the following commands on Precious with no password. Doesn't matter, we've already got the password. So let's just roll the dice here and run it. Okay. Oh, we want to run sudo. Still fails. Can we edit this? Update. Compare all installed dependencies with those specified in dependencies.yaml. This is just a stubbed function. So it reads this dependencies.yaml, which I assume is in the same path. And okay. Okay. Let's have a look in opt. Opt. Sample. Cat dependencies.yaml. Okay, so the reason it's failing is it can't find this dependencies.yaml because it's in this sample subdirectory, which is why we get no such file or directory. So slash opt read write execute read execute read execute. So can we? No, we can't. We only have read, write, execute, read, execute, read, execute. So we can't actually edit this script. Read only. So how can we exploit this? Can't edit it. So we can't even do no. Okay. Let's have a look at the sudo command again. User bin Ruby. Okay, so we can't run that. Or can we? Yeah, because it's going to have this update dependencies path. User controlled input into the update dependencies rb.script. It's the YAML file. Dependencies.yaml. But how can we get control of that if we can't edit the path in here? Because if we can install a gem, maybe we can install a malicious gem? Oh, wrong answer. What is the name of the file that allows for user-controlled input into update dependencies RB? What does setUID look like? Sticky bit. S instead of an X. Yeah. S. Okay. Opt update dependencies. User controllable file. List from file. Okay. Oh man, this is a little bit confusing. There's a reference to a particular path. There's a reference to a particular file which is specified without an absolute path. Yeah, I thought this would be it, right? But how can we hijack that? So so we can't inject one here where it expects to find it. Yeah, we can't create a symlink. Update allows for user-controlled input. Definitely missing something here. Sudo use path. Sudo user bin ruby test.rb. Sudo unquoted. Yeah. Abuse unquoted. Yeah, it's Windows technique. But it's not the sudo config, or the sudo is config that we're trying to abuse, according to this, right? Which is specified without an absolute path. So how do we mess with that? Because we can't edit the script. We can't launch a sudo elevated Ruby command because it needs to have this exact path. All right, I'm going to do something a little bit cheeky. I'm going to go to the write up because I'm out of ideas. Okay. Reverse. Okay, so this is the payload, and we put it into... Oh, because we run it from... okay. So, if we're in here, and we touch dependent... what's the file name? ls opt sample. We touch dependencies.yaml, and then we run sudo user bin ruby opt update dependencies ls. Okay. Yeah. So now, because the dependencies.rb script is going to look in the working directory for dependencies.yaml. Okay. Okay. Abuse Ruby YAML. Blind code execution through YAML deserialization. Ruby YAML exploits. Yeah, so... Okay. Okay. So how does this work? Right. Universal gadget. And we are running Ruby 274. So we would need this one. So we inject that into dependency. Seems to get cleaned up. Depend. dependencies.yaml. Oh. Let's abort that. And we just want to copy that. Then we want to run our sudo command. It's going to load dependencies.yaml, and it doesn't work. Oh no. It does work. So we just want to change that payload. Hey, keeps getting hosed. We just do that. Run bash. There we go. Who am I? ID. There we go. That is the root flag. Unfortunately, we had to go to the write-up to get that. Little bit disappointed, but it just didn't click with me, the whole absolute versus relative path. Still a lot of fun. Yeah, really enjoyed it. So just to quickly recap, we went and found that we were able to include an iframe, which gave us some ability to call back, but no way to really exploit. Digging deeper, we realized it wasn't this component, but it was PDFkit itself, which was vulnerable because it allowed an escape in the HTTP request, which then, when executed this at the command line, let us get a reverse shell. In the Ruby user home directory, there was a bundler config that has some credentials for the Henry user. Switching to that user, we had sudo access to user bin Ruby. And by exploiting the fact that the dependencies.yaml was a relative path, not an absolute path, basically this deserialization attack with yaml.load exists. And to Ruby's credit, they say this is bad, don't use it. But this gadget lets you effectively run a command, in this case bash. Cool. All right. Yeah, tricky one. I think it just emphasizes for me to think a little bit more broadly about how relative and absolute paths work at a file system. I just couldn't quite wrap my head around how to misdirect the input into that that's Ruby script running with elevated privileges, which is why we went to the write-up. Otherwise, we would be here for much, much longer. So it's been a lot of fun. And if you have stuck around to the end of this video, thank you very much. Have a great morning, afternoon, evening, or nighttime, whatever time it is for you. And I'll see you in the next video. Bye-bye.